As most of us in Ms. Devari's chemistry class know, the formula for hydrogen peroxide is H2O2. Comparing this to the standard H2O we're used to, this being the formula for water, we see that the extra 2 added onto the oxygen part of the equation means that there is more oxygen in hydrogen peroxide than water. Now, the objective and overall purpose of this elephant's toothpaste experiment is to facilitate and speed up the natural decomposition of hydrogen peroxide in H2O and oxygen. Once again, this type of reaction here is a decomposition, as opposed to a single replacement, double replacement, or a synthesis. A decomposition is a type of reaction in which we see a single molecule breaking down into one molecule or other molecules or smaller parts. For this experiment, 6 different materials are required. All of these are fairly easy to find, making this an accessible lab to most people. First, we'll need 60 milliliters of hydrogen peroxide. The hydrogen peroxide we use should have a 6% solution. Secondly, this lab initially calls for 5 grams of yeast, but for the purposes of our experiment, we will use 5 grams of potassium iodide. Third, you'll need 2 small test tubes, and the fourth material is enough dish soap to fill 1/2 of the aforementioned test tubes. The fifth thing this experiment requires is enough warm water to fill the other test tube completely. Finally, this lab requires us to have a 250 milliliter Erlenmeyer flask. Keep in mind, if you want to add any sort of food coloring, that's a totally optional thing. It won't affect the results of our experiment in any way. Now, there are 7 steps we will need to take in order to properly conduct this experiment. Step 1 is to fill one of our small test tubes halfway full with dish soap. Similar to step 1, we're next going to fill the second test tube fully with warm water. Step 3 of our experiment is to carefully and diligently pour out 5 grams of potassium iodide into the 250 milliliter Erlenmeyer flask. Now, this flask will serve as the basis of the experiment where everything is mixed and where we will record most of our observations. Step 4 asks us to pour the warm water into our test tube into the Erlenmeyer flask with the 5 grams of potassium iodide. We'll need to swish the water around for about 30 seconds or until we see that a clean mixture has occurred. Step 5 is also similar, as we're next supposed to pour out our half tube full of dish soap into the Erlenmeyer flask with our warm water and potassium iodide solution. Again, we will swish and mix the dish soap into the mixture until all the materials are indiscernible from each other. Because the addition of food coloring is optional, we won't count it as an official step, but this is where I added roughly 5 drops of dark blue food coloring. If you want to add food coloring to the Erlenmeyer flask, you can really do it at any point before now in the experiment. Now, this next step is probably one of the most important, as it rewards an instant catalytic reaction and chemical change among our reactants. Add all 60 milliliters of the Add all 60 milliliters of our 6% hydrogen peroxide solution into the Erlenmeyer flask. You won't need to swish anything around here, as the reaction should be instant. The final and next logical step in any experiment like this is to begin to record as many observations and collect as much qualitative data as possible, while maintaining a safe distance from the reaction, as it can heat up to a dangerous heat. But what exactly did I observe in doing this experiment? Well, there were a few surface level details which stood out immediately. Firstly, I noticed that the reaction happened almost right away, at least within the space of about 3 seconds or so. Foam began to erupt from the mouth of the Erlenmeyer flask and didn't stop for over 7 minutes. At about 7.5 minutes, we began to clean the mixture, but foam was still pouring out of the flask. Now, the second big thing I observed had to do with the color of the foam. Like I said, I had put about 5 drops of dark blue food coloring into the initial mixture, and when the reaction happened, the foam that came out was a sort of an aqua color, a lighter blue. We can assume this is because, well, as the food coloring becomes less concentrated and spread out over the foam, the coloring dilutes and becomes lighter. After about 30 seconds, however, the aqua color changed to a dark green, and from that, a rust color started to dominate the foam, with splotches of dark green present. Eventually, even as the aqua-tinged foam came out, a large rust-colored streak formed in the foam and permeated it. Now, this rust color is indicative of the iodide present in the reactants, that being the potassium iodide. As the foam started to pour out, it began to curl downward around the base of the Erlenmeyer flask. As it settled, the foam also lost volume, becoming thinner and thinner, and allowing more decomposing foam to stack on top of it. Eventually, however, the stacking became sloppy, spilling off the surface and expanding outward, even off the plate that the flask was sitting on. The next significant aspect of the reaction I observed is that after the foam had turned this green-brown color and settled around the base of the flask, it began to bubble and oxidize in the open air, and began to resemble, no pun intended, actual decomposition. So, speaking of real-world connections to our experiments, we see that hydrogen peroxide, the key decomposing reactant present, has multiple cosmetic uses outside of experiments like this one. Firstly, this product can disinfect small wounds. Hydrogen peroxide is a natural antiseptic, meaning that probably its most common use is to clean wounds, in order to prevent infection. Secondly, hydrogen peroxide can bleach your hair. This is because it is more gentle than household bleach, and it's a natural hair lightener. Just put it in a squirt bottle and spray it over your damp hair, letting the hydrogen peroxide soak into wet hair for about 10 to 15 minutes, before rinsing it out. There's also quite a few uses for hydrogen peroxide in the field of oral hygiene. Hydrogen peroxide can be used to form a natural whitening paste for your teeth simply by mixing it with baking soda. This is a great stain remover as well as the antiseptic it can serve as. This cleans teeth and kills germs, saving your breath too. If you soak your toothbrush in hydrogen peroxide, it can kill staph bacteria that's commonplace in most bathrooms. Now, as well as whitening your teeth, hydrogen peroxide can also whiten your nails. Soaking your fingertips and toes and a bucket of hydrogen peroxide for a few minutes can whiten them naturally as well. It also has multiple uses in dermal cleanliness as well for your skin, such as cleaning up acne by using hydrogen peroxide as a face rinse to help smooth out a naturally oily complexion. And pouring half a bottle, which amounts to roughly 8 ounces of hydrogen peroxide, into a normal-sized bathtub and soaking in it heals boils anywhere on the body, which can be very dangerous. Another great H2O2 based skin treatment is a callus remover, made by adding equal parts hydrogen peroxide and warm water into a mixture, and soaking your feet in it. It can also kill subdermal parasites like mites, simply by applying it to your skin, and it can also kill tapeworms this way. And finally, since light skin weakens the strength of hydrogen peroxide, putting hydrogen peroxide and an equal amount of water in a dark colored spray bottle and spraying your feet every night with it will kill foot fungus as well, which can prove to be cancer causing later in life. Now, these last few uses all have to do with aiding our ears. First, we see that hydrogen peroxide can help remove earwax, simply by adding a few drops into your ears, followed by a couple drops of olive oil, believe it or not. Now, after draining your ears, they should be all cleaned. Not only is this method of wax removal very safe, but it's also very effective, believe it or not. The next great use of this product is that it prevents something called swimmer's ear syndrome by making a mixture of equal parts hydrogen peroxide and vinegar, putting it into a small dropper bottle, and putting it into your ears. Now, swimmer's ear is an infection that affects multiple swimmers every year, and it's a very painful experience that hydrogen peroxide can help solve. Now, I know what you're thinking. These sound like recipes for an ear infection, right? Well, that's why this next use of H2O2 will surprise you, as putting 6 to 8 drops of hydrogen peroxide in each ear will actually help alleviate ear infections and take away bothersome symptoms. These are quite a few uses beyond what we normally see, but they are common enough methods of use to be tried and true successes. Obviously, however, the most common use for hydrogen peroxide, and the reason it's under most of our sinks or in our medicine cabinets right now, is to alleviate cuts and wounds. I mean, how often as a child would our parents put hydrogen peroxide on our wounds to help clean our skin? But just what exactly happens when we pour hydrogen on a wound, and how do we examine the science behind what happens? Can it be related to this experiment in any way? Well, let's say you pour hydrogen peroxide on an open wound. Your flesh contains a special enzyme called catalase. Now, catalase's job is to attack and ultimately decompose the hydrogen peroxide, breaking it down into oxygen and water, and thus killing dangerous bacteria. We see a clear reflection in this lab, right? Hydrogen peroxide decomposing into water and oxygen, whether it's in an Erlenmeyer flask or in our skin. We can see that in the application of hydrogen peroxide to our skin, the enzyme catalase acts as the catalyst. They have the same root word. So an easy trick to remember this is by thinking of their similar root. The catalase speeds up the transition state among the reactant, hydrogen peroxide, right? And removes it much faster towards the final decomposed products, which clean our wounds. This is an excellent real-world use of manipulating decompositions and the release of oxygen to our advantage. So since we see this clear reflection, and we see multiple uses of hydrogen peroxide, we see the real-world helpfulness of this lab, which allows us to internalize it, learn its lessons, and carry them with us into our everyday lives.